Good morning, everybody. Welcome to the webinar. We're going to be getting started now as it is noon. I guess I could say good afternoon. Let me get the screen started. Good afternoon. Welcome to the webinar sponsored by Santomassimo Davis, Outside General Counsel Solutions. I'm Alex Anglin, one of the partners at the firm. I'd like to tell you a little bit about ourselves before we get started. We're a boutique law firm that focuses on serving mid-cap companies with our outside general counsel offering. With that offering, we deliver services in a way that replicates an in-house legal department for companies typically that are not large enough to have their own in-house legal department. We integrate closely with our clients, get to know their business, and become a virtual law department as a resource for them on matters large and small. And in doing that, we can provide and often do provide our services on a fixed fee basis or a project basis to help our clients manage their legal spend. Now, a little bit about today's program. This program that we're doing today is part of a series of webinars, which some of you might have joined us for previous webinars, some not. But we have done, I guess, about 4 or 5 of them now as part of a series that began after the COVID-19 crisis. Our intent in doing these presentations was to provide you as business leaders with information that you can use to create your company's own pivot plan. And we've used that phrase repeatedly throughout them, meaning that you're going to pivot from this crisis to get back to business and to thrive in this new environment. Hopefully not just to get back to where you were before, but to create a foundation for an even higher level of success. Our early webinars, the first few in this series, were primarily focused on legal issues like the CARES Act, payroll protection loans, HR, and employment law issues, things like that. Now we've moved into some different material in this series, which is more focused on keeping your employees safe in this new environment. And we, of course, don't know how long this environment is going to be the way that it is, what the changes are that are coming, but some things can be learned now, and we're going to be getting into that in some detail today. Our most recent one, for example, dealt with a lot of in-office issues like personal protection, dividers, office furniture, workspace configuration. And that was all brought to us by an expert, Steve Lang, the CEO of Danker, whose company specializes in that area. In an upcoming webinar, not today, but you'll be soon seeing an invitation about that, we're going to be dealing with some technology and legal risks that are closely related to the increased emphasis that we now have on employees working from home. And that is something that's been brought on by the crisis, but it's probably going to be staying with us for a long time, presents some new issues, and we'll be delving into that in some detail in our next installment in this series. Today, we're going to be focused on issues related to your business's physical environment. Office space, manufacturing facilities, whatever. I mean, each business is, of course, different, but there are some principles that are going to apply to all of you. And we're going to get into that a little bit today. During the presentation, we're going to be touching mainly on issues that are the province of mechanical engineers, specialized contractors, mainly how the safety considerations after COVID-19 are affected by heating, ventilating, and air conditioning systems. And we're fortunate today to have with us a real expert on that subject. It's Jim Trynoski of the Falcon Group, where he's an executive vice president. Falcon Group is a full-service engineering and architectural firm, primarily serves the owners of existing buildings. And Jim is part of the MEP and Energy Services Division. MEP stands for Mechanical, Electrical, and Plumbing. It's a common acronym in the industry. And with that group, Jim designs and specifies mechanical systems for buildings that group that he's a part of at Falcon also does inspections, troubleshooting, building commissioning, and other MEP-related services. Jim personally has extensive experience with HVAC system design, which includes both new construction and projects within existing buildings. And now we're going to start to touch upon briefly some of the things that Jim is going to cover in his presentation, which is that his experience is particularly focused on maximizing energy efficiency of these building systems, these very important systems which use a lot of energy. And that energy efficiency has been a major industry focus over the years, and Jim is an expert in that area. And we're going to see today, when Jim begins to present this material, that some of those considerations are going to be maybe taking a back seat now to some safety related considerations and are going to require some changes, and it'll be very helpful, we think, for you to know a little bit about them, become conversant in them, and be ready to interact with folks like Jim when you're dealing with restarting your own operations. So with that, I'm going to turn the presentation over to Jim, who's going to share his screen. I'll stop sharing mine. And while we're doing that and switching over, as soon as Jim gets his screen up, I'll mute my line and turn it over to Jim.
Thank you for the introduction, Alex. I guess I'll I have the slideshow up on, sorry. The slideshow up on my screen. And
All right, that's good, Jim. We can see your screen. Yep, we can see your screen, so take it away.
okay, great. Thank you for the introduction. Good afternoon, everyone. As Alex said, my name is Jim Trynoski. I'm the manager for Falcon's MEP Energy Services Department. We assist our clients with evaluation, design, and construction administration for replacement and upgrades of their HVAC, electrical, and plumbing infrastructure. A little bit about myself. I've been with Falcon for about 8 years. Prior to that, I worked with an international firm on large transit, school, and wastewater treatment infrastructure projects. Currently, we're working with large multifamily residential clients, as well as some commercial office renovations and fit out, and various energy improvement projects with different clients. I hope everyone has stayed safe and healthy during these challenging times. Myself, I have 4 children, little guys. It's been a challenge, obviously, for the last 9 weeks to kind of manage that with everyone staying home and no school. So I hope everybody's doing well on that front. Now that there seems to be some light at the end of the tunnel as far as reopening plans and local governments talking about timelines for getting everyone back to work, we thought it would be a good opportunity to discuss some high-level information on different types of building HVAC systems, how they work, how they might come into play as far as reopening strategies and the health and safety of the building occupants. We'll touch on a few different subjects this afternoon. We'll focus on different types of HVAC systems that you might find in buildings and how the impact of the spread of infectious disease, obviously the current situation with COVID-19, could play a role in how we think about them in our buildings. We'll talk about different recommendations for system modifications that might be considered based on the types of systems and equipment you have in your buildings. And we'll talk some operational performance modifications or standards we can work towards to try to improve how these systems operate under the current circumstances and how it relates to guidance from various industry organizations. Most of the guidance recommendations in this presentation come from ASHRAE. ASHRAE stands for the American Society of Heating, Refrigeration, and Air Conditioning Engineers. This is a trade organization that develops many of the standards for ventilation, HVAC system design, and energy efficiency that our building codes are based on. ASHRAE has been providing updated guidance since the onset of the current pandemic as far as best practices for building system operation and design to mitigate the current circumstances. I started fielding calls from clients in early March regarding operation of their building ventilation systems. Since then, we've been reviewing guidance as it comes in order to develop strategies and respond to the requests of building owners and occupants. As we learn more about how the virus is spread and the science behind it, as more and more studies are done, these guidelines are likely to continue to be updated with new strategies being developed. Moving forward, if you have any concerns or questions about how your systems are set up or maybe operating, you should consult with qualified contractors and design professionals to gain a better understanding of what you have in your building. So we have there's many different types of systems installed in buildings, and the building owners, designers, and contractors that specify and build these systems take a variety of different factors into account when deciding how to condition interior spaces. Some factors that are considered are building orientation, building construction, occupancies, activity type, and of course, cost. A few general system categories, and this is really high level: central plant, split systems, VRF systems, and ventilation systems. I've tried to put them into kind of a few categories for discussion. So central plant systems, larger buildings may be provided with a central heating and cooling plant. This would typically include chillers, hot water or steam boilers, pumps to circulate the hot water or cold water or chilled water through the buildings. And depending on the type of chiller, there may be cooling towers involved. There's obviously all kinds of other auxiliary components and controls that work to keep these systems up and running 24/7. One of the questions, and the reason why I'm touching on this, was asked by a client a few weeks ago if there was any concern with water circulating through these systems as it relates to the spread of COVID-19. These systems are generally closed loop systems, meaning that the fluid, in most cases, water or a mix of water and glycol to prevent pipe freezing, circulate from the mechanical room through the building to the point where it's used at a terminal piece of equipment like a fan coil or a small air handling unit or a large air handling unit, or unit heaters in maybe some areas, in the utility spaces and things, and then back to the mechanical room. These systems are chemically treated to protect the system from corrosion. And there's really no opportunity for the spread of disease as it's not coming into contact with the environment or any of the occupants of the building. Cooling towers that are not properly maintained could present an issue with Legionella. I'm sure we've all seen that in the news, over the past few years where there's been outbreaks from that. But assuming they're being cleaned and treated properly and meet the guidelines, that they're far enough from any air intakes or openings to the building, it wouldn't pose a threat to the building occupants, in this context. That's certainly something that needs to be looked for. But that's kind of something that's always with us as opposed to, the current crisis that we're in. The next type of systems we'll talk about, split systems. They typically have an indoor air handling unit or heat pump connected to an outdoor mounted condensing unit. They're connected by a refrigerant circuit. These systems heat and cool the spaces they serve as well as provide ventilation. They're generally recirculating into the space. And there should be a fresh air connection introducing a certain percentage of outside air into the building to keep the place ventilated. If there was a concern for the spread of infectious disease via airborne droplets, this would be the system type that I think most people would have questions about and want to make sure are operating correctly to mitigate that risk. VRF systems, that stands for variable refrigerant flow. These systems have been around internationally for many years, but they're becoming increasingly popular in the United States. They include an outdoor condensing unit or heat pump, much like the split systems, but they serve multiple indoor units. Typically, there's an indoor unit in each occupied space or multiple units in each occupied space, depending on the loads and the size of the space. The indoor units are controlled locally, and the systems, depending on the layout, can provide simultaneous heating and cooling of different spaces with different occupancies and cooling and heating loads. These systems generally operate independently of any common ventilation systems, although it is possible that there's fresh air being ducted directly into the indoor units, depending on how the designer and contractor laid it out. Much like the central plant with the local terminal equipment like fan coils, these units generally serve only the spaces they're installed in, and they recirculate that air, though there are some larger indoor air handling units that could also be connected into these systems. Ventilation systems, I think this is the main focus of a lot of the questions that we've had. Ventilation systems could serve several purposes. Like I had mentioned in the split systems, where you have smaller indoor air handling units providing climate control and ventilation to a space. There may be larger systems that are heating many spaces. We're talking large rooftop units, and then there may be systems that are dedicated to only providing fresh air or makeup air to serve ventilation needs of the occupied spaces. So that's a type of system, a dedicated outside air system that would be installed alongside a VRF system. So you're handling the space heating and cooling loads with the VRF system, and you're managing the ventilation requirements with a dedicated outside air handling system. And then there's larger systems that combine both of them. You're providing a large amount of fresh air for ventilation and also heating and cooling the spaces with that airstream. It also includes things like exhaust systems for bathrooms and kitchens, general space exhaust from process areas. And a lot of the questions that I've gotten, especially in the beginning, was related to shutting down these systems because there's a concern that air could be migrating between spaces from one area to another. And the recommendation has been to keep these systems operating, because not only do they help condition the space in many cases to make sure it's comfortable and there's no damage to the building and elements by not having the right humidity levels, but it's also because the exhaust air that's being removed through those exhaust systems is being displaced by fresh air from the supply air systems, and we want to make sure that we're always bringing in fresh air into the spaces. Okay, so as I noted, the ventilation systems are where most of the concern is related to the spread of disease in a building. What can we do to improve these systems or modify them to limit that concern? There are several improvements and recommendations we can look at based on the latest guidance from ASHRAE. These may have impacts on the overall system performance and the configuration of systems as they are installed and originally specified. There may be some limiting factors in accomplishing some of them. So we have increasing the ventilation rates. We can look at improving the filtration setup that we have in the equipment that we have installed. We can look at changes in the time of operation, and we can look at bypassing energy recovery systems. Unfortunately, because there's so many different types of systems and equipment, there's not one size fits all recommendation. I wish there was, because that's kind of the question. Oh, what can we do to make sure that everything's running tip top and condition and is keeping everybody from spreading this around. But there's so many different configurations. Each system kind of has to be looked at individually as to how it's performing, how it's set up, and how it what changes can be made. The first recommendation is, wherever possible, we want to look at increasing the ventilation rates of the occupied spaces. Code requirements have changed over the years. Much of this guidance has been based on the desire to improve energy efficiency and how we understand these systems to operate, based on improved airflow modeling, based on the technology changes that have happened over the past few decades. So I can remember back in 2004, ASHRAE updated their standard 62.1, which is the ventilation guidelines for occupied buildings. And there was a shift from specifying a minimal amount of CFM, that's cubic feet per minute, of fresh air per person, to a combination of CFM per person, and it also basing it on the square footage of the occupied spaces. What happened with this was it reduced the requirements in most cases for fresh air into buildings, which is great for an energy consumption standpoint because you're not heating and cooling so much fresh air during peak load conditions. But maybe looking at it from today's vantage point, it may not be as effective as in mitigating the spread of some of these viruses. It's also important to consider that many systems for smaller commercial spaces or older systems may not function as they were originally intended, and they may not have the required connections for outside air being introduced into those spaces. This should be evaluated to make sure that the current code requirements are being met and the same stagnant air is not being constantly recirculated through the space. You may need an HVAC design professional or contractor to help assist with this. When I started my career, I worked in a brand new building that had 4 split systems serving 4 zones, and there was no fresh air connection to any of those systems. I remember when someone would come into the office sick, it would only be a matter of days before it would spread through the whole office, and then you'd have a tremendous amount of absenteeism. It's ironic that a company specializing in HVAC design would have such a poor building ventilation system, but it's probably more common than not. The first step, as I said, would be make sure that there is fresh air coming into the building or space in the correct quantity. And then that may require an inspection of the existing system and the ductwork and where that connection to the outside would be. And then another option being presented by ASHRAE is to enable the use of economizers on larger systems. These are required based on energy code. And basically what they do is when the outside air conditions are right, humidity and temperature are at the correct levels to provide free cooling to those spaces without adversely affecting the building, dampers will open and bring in more fresh air than what the system is designed for in order to take advantage of the free cooling. It's being recommended to kind of force this mode on where possible to increase the fresh air flow into the building, but that may not be possible under all conditions because the systems are sized for that minimal amount of fresh air, not the full amount of fresh air for the whole system. So it would be important to look at the sizing of the heating and cooling coils and the associated equipment to make sure that the system is capable of performing as it's supposed to under those conditions. And then, finally, we would want to look and see that the systems are properly balanced over time. People adjust dampers, people change, people put up cardboard over the air outlets. I have some of that in my office. Things change or things were never properly commissioned when the system was first installed. So it'll be worth having a testing and balancing contractor come in to measure the airflow in each space to see if the system is performing as it was originally designed. And then you can make adjustments to make sure all spaces are getting the proper airflow. The next thing we can look at is improving filtration. This involves, stepping up the frequency of when filters are changed and assessing the type of filters in use on your system and what might be available as a substitute. We have MERV listed here, MERV, that stands for Minimum Efficiency Reporting Value. This is a scale that was developed by ASHRAE to measure the performance of filters. They are recommending a MERV 13 filter to better capture the droplets and particulates in the air associated with the spread of infectious disease from being recirculated into the system. MERV ratings 13 to 16 is generally what's used in hospital and surgical settings, but many commercial and residential systems may be installed with, a lower rating like a MERV 8 filter. So what needs to be looked at for this recommendation is the ability of the system to accommodate the better filters and the performance of the system with the new filters. A better, more efficient filter will have a higher pressure drop, especially once it starts collecting dust and debris, and the installed fan may not be able to overcome this pressure drop. So it's something that has to be monitored carefully. You can't just switch the filter out, and it may not fit in the filter space that's designed into the existing piece of equipment. So long-term solution, wanting to increase that filtration permanently, the air handling unit itself might need to be replaced or modified, and that would be a large cost item, obviously, for everybody, and subject to long lead times. It's not something that you'd be able to do overnight necessarily. Changing the operating schedules is another recommendation. So they're recommending that, since so many building automation systems and thermostats, smart thermostats have timers to schedule or shut down ventilation systems when buildings are in unoccupied mode, the current guidance would be to override these settings to keep the systems operational, to keep removing the exhaust air, capturing airborne particles in the filters, and constantly have that exchange of fresh air in the building, even when it's not fully occupied. Finally, bypassing energy recovery systems. Again, this is, as technology has progressed and systems have become better with more features, modern air handling units that have supply and return and exhaust components built into them are required over a certain size to be equipped with energy recovery modules. And these are basically heat exchangers. With the old air being exhausted, it's used to precondition the fresh air to reduce the operating costs of the HVAC systems. These devices are pretty good at preventing cross-contamination, but for now, they're recommending it's maybe better to disable them if possible to prevent anything in the exhaust airstream from accidentally cross-contaminating with the fresh air that we want to bring into the system. I remember looking at some of these units a while back as it relates to casinos where they still have smoking and stuff allowed, and it's pretty incredible how efficient they are in preventing that cross-contamination, but it still exists as a possibility. So we want to mitigate that as much as possible. Again, this is going to have potentially an adverse impact on the operational costs depending on what time of the year the system is operating, because you're not going to have that preheating, pre-cooling mode from the heat exchanger working the way it's supposed to. And the system may not be sized, to run at full load if it's taken into account that energy recovery function needs to be operational. So it's something that's going to have to be looked at by a design professional. We can also take a look at changes to operation and control in of the indoor set points and local measures in the spaces that can possibly have a big impact in helping improve the safety of the occupied building and preventing the spread of the infectious disease. There's several recommendations that have been made or areas that should be looked into by ASHRAE concerning this, looking at, again, the ventilation rates, looking at humidity control, and looking at the local filtration and possibly UV light installation. So we talked about ventilation a few slides back, but there's some additional considerations, that I think, warrant further discussion as far as improving the ventilation rates. So we discussed that, the contaminated air is being displaced by fresh air by keeping these systems operational. We want to make sure that we're inspecting to verify that the outdoor connections are present and functional, that we're bringing in that fresh air to the building all the time. And then we want to look at improving the distribution of air to promote effective ventilation. And one of the things I talked about with Alex as we were putting this presentation together was you may have an older office space or even a newer office space that's been reconfigured many times over the years. So it's important to, if there hasn't been a focus on updating the HVAC in that space over time and everything's worked, everybody's comfortable, maybe there's some minor complaints about who has access to the thermostat, but generally speaking, everybody's happy and healthy. But say, for example, you have two offices next to each other that were converted to a conference room type setting. That change in space usage and occupancy is going to require an increase in fresh air for ventilation purposes to that space. And there may be some reconfiguration on the system side as far as the sizing of the air handler, the distribution of the air to that space to accommodate the additional cooling load from having the extra occupants, but also from a ventilation standpoint to make sure you're introducing enough fresh air into those spaces to meet the code requirements and make sure there's a constant air exchange in the space. So it's important to kind of do a inspection of those systems and the spaces to make sure everything is still operating and laid out, designed to meet the requirements of the usage of that space. Humidity control is becoming a very important topic with this this particular pandemic. We've always, as HVAC engineers, we've always designed to a certain relative humidity requirement in the spaces, and generally it's in that target that I have listed here, 40% to 60% to get in that range. But I never really was familiar. I'm not a doctor. I'm not an infectious disease specialist. I didn't understand the why it was so important. And I had taken some classes a few weeks back with some doctors kind of presenting this, and it really optimizes the human body's response mechanism to preventing infection in people by making sure you're properly hydrated and your mucous membranes are where they're supposed to be instead of being dried out. And also with the particulates and the droplets that we hear all about while we're wearing masks and to protect other people from ourselves when we're in close quarters. When the air is too dry, those droplets can get desiccated and they travel a lot further when we sneeze or cough, and they'll persist longer on surfaces when that happens. When the humidity in the space is properly tuned, they don't dry out. They're heavier, they don't travel as far, and they can get picked up in this filtration media that we've discussed in the past slides a lot more easily than when it's too dry. And it's funny, I'm sitting taking a webinar class on how to monitor this and why it's so important, and I have a sensor in my office that tells me what the relative humidity is, and I look over and it's 40 to 60%, and I'm at 10%. So I think that's very common in a lot of office environments. So how do we deal with that? It may be something to consider to retrofit humidifiers into the HVAC systems, and that would require looking at how the system is set up, where the ductwork is, what kind of humidifier would we want to install? Would it be electric? Would it be gas-fired? Would it be steam if there's steam in the building? There's many different types of products that can be looked at, but I think this is something that's going to be very important moving forward, especially if we're going to be living with this for a long time. Finally, we'll touch back on filtration again, and also ultraviolet disinfection, where HVAC system upgrades may not be possible, and especially in areas that are kind of high occupancy, high use, like a waiting area or a reception area, conference rooms, where people are collaborating in close quarters, it may be, it is recommended to install portable HEPA filters with a high MERV filtration level to kind of help remove some of that particulate and the droplets from the air by recirculating it through these filters in the spaces where there may be a lot of people present. And they're also, we can also look at evaluating for this ultraviolet filtration if it's going to be installed in ducts. And there's portable units that can also be installed in high occupancy areas. That'll pull in the air, it'll expose it to the UV light, and that will help. It has a high effectiveness in killing the virus under those conditions. I was just looking at some of the suppliers for this equipment. It looks like a lot of it is going to be on back order for a while, so it may be a challenge to procure some of these things. But these are some of the recommendations that the leading industry professionals have been making over the past few months. Was I on the wrong presentation, Alex?
Nope, you are fine. And the next slide was just going to be our question and answer slide.
Okay.
So it's not urgent that we get that up there, but I will.
We can switch back to you.
We could do that, and I'll share my screen. While you're doing that, I'll just say thanks. It was very informative. I'm going to get into just now a little bit of a question and answer to bring some illustrations, some practical illustrations about what your particular concerns might be as you. Oh, you're still sharing, Jim.
Yeah, I don't.
Don't worry about it. Just put
I
that
see.
slide back
Switched to
up
my other screen. I'm sorry.
Put that slide back up and we'll keep rolling. All right. So the first question I want to prompt you with, Jim, is one of the things you mentioned in the presentation was the possibility of improving the filtration. And it occurs to me, and I think it may occur to some of our audiences, is this an area where there might be some improvements made at relatively modest cost, right? As opposed to, some of the maybe more significant projects that might involve with new equipment?
I think so. It depends, because if the system is capable of accepting a higher efficiency filter, then I think it would be something that it should be readily available to buy them, depending on the size to fit the unit. But it's really going to depend on the equipment that's installed currently, because we have fans that are sized to accommodate a certain pressure drop through the ductwork, and the filter and the heating coil and the cooling coil. And when you start making changes to that, it can affect how the equipment performs. So it's something that needs to be looked at, but it should be possible to make some improvement at a reasonable cost, I would think.
All right, maybe related to that as well, one of the things that clients are talking to us about, and I'm sure are going to be talking to you about as well, is that their operations, when they resume, might not look quite the same. Right? For example, it might be asking people to come in, for want of a better term, in shifts. Maybe half of the office shows up one day, half of the office shows up another day. And if tenants and occupants are doing that, is that something that you as an engineer can take into account as far as whether the systems are going to be good enough or need to be improved to keep people safe?
Yeah, I think when we look at a space and we start designing the HVAC and ventilation, we assume, usually based on input from the owner or the tenant who's directing the space to be refit, and the architect who's putting the architectural plans together, we account for a number of occupants in each type of space. So in a situation like I find myself in presently in my office, we're on a rotation. So we have in my little office with my team, we have 8 people, and we kind of have only 2 at a time in the space. So that we would be getting additional advantage from the ventilation for the full number of occupants with the limited number of people. So that's, definitely something that could help and that, could be assessed.
Right. I thought it would also be useful for me to just chat briefly about the interaction of the legal side of things and the engineering advice that your firm provides. And it's the first starting point for that, assuming that a business doesn't own and occupy its space, assuming it is a tenant of space that's owned by somebody else. The first starting point for them and for us as their lawyers is going to be the lease. But we could tell you now it's very unlikely that you're going to find very clear guidance in your lease regarding these subjects, right? This is not something that the drafter of a lease a year, 2 years, 3 years ago would have been thinking acutely about, right? Safety of disease transmission vectors in their HVAC systems, and who's going to be financially responsible for making changes if they need to be made. So the starting point is that things are probably going to be less than clear, and that's being kind when looking at the lease. There may be some things that are important for us to look at as lawyers, like force majeure clauses, but probably you're going to have to need to really sharpen your pencil with your counsel, with your outside counsel, in looking at your lease and determining what your rights are and what your obligations are vis-a-vis your landlord, right? So you may be seeking some of the improvements that Jim pointed out are possible and will be helpful in keeping your people safe. However, it may not be clear who's going to be bearing the financial responsibility for those changes. So that's something that, again, you're going to begin to work with your counsel about that. These issues, in all likelihood, and again, you'll speak to your counsel about it, but in all likelihood, these are going to be subject of negotiations between the landlord and the tenant. And that negotiation, that position that you take, is probably going to need to be informed by somebody like Jim, right? So regardless of whether you start maybe by calling our firm in the first instance, or by calling somebody like Jim in the first instance, at some point, probably the lawyers and the engineers are going to end up working together to get you to a point where you determine, what can be done, what needs to be done, what can be done, and who's going to bear the cost of that intervention. So with that in mind, I'm wondering, Jim, if you think, is it a good idea for tenants now, as they're maybe before they're even getting back to operations, a good idea for them to reach out to an engineer or a contractor and maybe do an audit of their existing space and the systems that are there?
Yeah, I think that would definitely be worth considering, especially if there's concerns about if it's an older system, or maybe it has some operational issues. You have trouble maintaining comfortable indoor air climate control. I think it would be a good idea. I'm noticing one of the comments, and it reminded me of something I think I skipped over, talking about the 40 to 60% humidity, if I can step back to that. So Nancy asked if the 40 to 60% humidity will affect the copiers and the electronic equipment. I think that's a normal range. It's what we would be typically designing to anyway, so I don't anticipate there would be an issue with any electronics located in the office environment. It's certainly something that can be, double checked with the manufacturer's specifications for that piece of equipment. But another thing to consider with the relative humidity range that we discussed is a lot of older buildings may not have a building envelope with the insulation or any insulation that could prevent the surfaces from having moisture condense out on them. So if you have a brick wall with no insulation in it, and it's 13 degrees outside, and you've got moist or air during the winter at a 50% relative humidity, the surface of that wall could be below the dew point. So it's possible that some condensation could form, which could be a mold hazard. So that is something that I think needs to be looked at before you add a humidifier or something onto your equipment. Is it going to have an adverse impact on other health aspects of the building? It should be looked at if there's improvements that need to be made. An architect should be consulted, or an engineer, to see how you might be able to get around that.
And related to some of these, very early in the presentation, you were talking about some ventilation systems that might be required in, depending on the usage of the particular space, right? Like a manufacturing environment or a shop environment. And one thing that jumps out is whether, as a result of those, maybe the manufacturing environments, warehouse environments might actually be better suited or more easily adaptable to these concerns we're having now about the spread of disease when compared to, for example, office environments where some of those systems, ventilation systems, were not required as a matter of code.
Right. Yeah, it's a good point, because I think when we first got into the ventilation topic, I mentioned that ASHRAE 62.1 standard changed in 2004, and all the building codes kind of adapted to over several years to mirroring those recommendations, which reduced the requirements for ventilation air in most cases. In the cases that you just mentioned, warehouses, storage areas, manufacturing, where there's maybe a lower number of occupants normally in those large footprint buildings, those ventilation requirements are based on square footage and the occupants. So in those cases, some of the ventilation rates may have increased as a result of that change that they made 16 years ago. But there's also considerations there. If you're not conditioning that space with air conditioning, it's more ventilation only. You're going to have higher ventilation rates to kind of move some heat away from those manufacturing processes and to keep people comfortable. They have typically spot heaters and stuff in the wintertime instead of trying to heat and ventilate a massive facility with a huge volume. So I think those could be advantageous in dealing with this, that we have such a high ventilation rate.
All right, and I think for maybe the last topic or concluding topic unless we get another question in the next minute or two, one of the things you brought up was that ASHRAE, gave some guidance very recently. I think you said April, after the crisis began. Now, we as lawyers, we've seen, for example, the CARES Act has been developing day by day by day. So webinars that we gave in early April, we got more updated information mid-April, late April, early May. We keep getting new information, new guidance. I wonder if you as an engineering professional, are you expecting to see more developments as the days and weeks go by from ASHRAE or maybe even from other sources that you'll be looking for?
Yeah, certainly. I think, dating back to maybe the second week of March, I think I first started noticing, I'm on their mailing lists, obviously, so I get updates from them on normal run-of-the-mill, stuff. And then obviously with the, COVID-19 situation, they've been updating that guidance periodically. So I think the last version that came out was mid-April. And I fully expect as we gain a better understanding of how the disease spreads and what might contribute to it spreading and what might help it from spreading so much, there'll be continued guidance and changes to this and further developments.
All right, great. I want to thank you, Jim, for your time, for the excellent material you provide us with that our clients and friends can take into account as they develop and execute their plans for resuming operations, for getting back to business, and hopefully to even increase their levels of success while they keep their people safe. I hope everybody found it to be really valuable. We would certainly like to hear from people in the near future. We've got our contact information up on the screen. Please do feel free to email us, reach out to us if you have questions. If you're interested in learning more about Jim's practice, about the Falcon Group, please do that as well. I think that probably just about wraps it up for today. I look forward to reaching out to everyone by email with the details of our next webinar, which, as I said, we expect will cover issues related to technology and legal risks that are driven by the new emphasis of working from home, and how, for example, you may have accounted for that as a possibility in your overall business planning, but you may not have really thought it through to the extent you need now because of how prominent a feature that's becoming in your day-to-day operations, things like your information systems and the risks and other factors that arise out of that. So I hope to hear that everybody will join with that webinar, and I hope everybody will get a lot of value out of that as well. So again, Jim, thank you very much. Much appreciated. And with that, that'll end the webinar. Thanks for everyone for joining us.
Thank you for having me.